Hello, I'm Paul Beckwith. I'm talking about how the energy of waves can really have a huge impact on coastlines, especially with these massive storms that we're seeing. You know, just in the last week, we had this massive nor'easter go up the eastern coast of the U.S. And this week there's another one occurring, and there's yet a third one on the weekend. And we're getting massive reconfiguration of coastlines. So this series of videos, this is a continuation of the previous two videos, and I'm talking about some very rugged coastlines in different places. Ireland to start off, and how these huge massive boulders, up to 620-ton boulders, were actually moved just in a series of storms that hit that region in 2013, 2014, the winter. So this is an image of one of the coastlines here, and I thought it was from a drone, but it's actually it's from Google Earth, data acquired 2005, showing the morphology. So the bigger boulders are here. As you go up here, you get smaller and smaller boulders. That makes sense. And this is a view, a close-up view here. Okay, and this is a notebook here, just to give you an idea of the size of these boulders. Okay, this is another region here, Inishmore Island. Inishmore, there's a series of 3 islands, the Aran Islands off Ireland, and Inishmore is one of them, and there's a cliff here, and these boulders are seen here with the scale here. This is a helicopter flyover in January 2014, and this photo was taken in July of that year. Okay, so you can see the size of some of these boulders here, and these large boulders were moved to these positions between January and July of 2014. Okay, so those storms actually moved these boulders. The wave action was large enough to move these boulders here. Okay, so they moved. This was their original location. So this was a helicopter flyover in January of 2014. This is where the boulders were, and they were moved here. This was moved to here, and this one was moved to here. And you can see the scale here, and it was moved between. So the location at the tips of the arrows was in July of 2014. The circle locations was in January of 2014. Okay, and the boulders are all itemized here and given numbers, so you can get the masses and stuff. I mean, these are massive, massive boulders. Okay, here's another view of Inisheer, which is one of the islands in that region, next to the other island off Ireland, and this is what happened. Okay, so basically what happened is those storms in 2013, 2014, the winter, they excavated large rocks from this region here, and these rocks were deposited here. So they were moved in those series of storms. Okay, and this is to give you an idea of the scale. This arrow here is this location here. This is the size and the height of this boulder field here. Okay, you can see the boulder field up here. The white areas, the boulder field was actually pushed back. These white areas were where the boulder field was before these storms, and the boulder field was actually pushed back in those storms. You know, here this white area too, the white area is here. So this massive pile of rocks was shoved along. Okay, here's another view here. This is an image, I believe this is taken images from a UAV in June of 2016. And this is showing you a close-up. This is a person here, and this is the size of the boulders that are actually being moved by this storm. Okay, now this is interesting here. So I'm gonna go to a larger scale so you can see. So this is a picture taken. Let me go again here so I can get it. Okay, so this is in 2013. This was a photograph taken in 2013. This is a photograph taken in 2014. Try to get it in here. Let me, okay, here we go. Get the whole thing in. Okay, line it up. Okay, so what you can see is, you can see that these boulders here, you know, are in the same locations. But, you know, look what's happened here. Okay, this was here, all of this was torn up, maybe upended. You know, you can see it looks completely different, right? This whole region, you know, where did this go, for example? Was it broken up? Was it shoved up and broken in half? Right? You can actually study. It brings up an interesting story. There's this old geologist who retired and lived along the St. Lawrence, and he drilled holes in rocks and he put all these GPSs in the rocks. And he measured the motion of them over years. He was retired, so I don't know, he didn't want to just watch the rocks so each winter, as the ice piled up along the shore, the boulders would move and stuff, and he could map how they would move. So, you know, we haven't done that. This hasn't been done here, but, you know, these pictures show strikingly how the whole configuration of boulders has been changed from the storm action in winter 2013, 2014. Okay, so here's another one. Let me just center it. Okay, so in 2013, you know, this was here, this was here, this is the type of situation here. This area here corresponds to this area here. So those storms actually took this entire rock here and they ripped it into pieces, and pieces were dumped. Pieces were dumped here, you know, here. It's totally different, right? It's totally different. Some of the bigger rocks weren't moved, right? But this was the water came under, lifted this whole thing up, shattered it, you know, completely changed the coastline, just from those storms. And this was on Inishmore. Okay, the fragments were shunted up, different new boulders were created, and so on. The platform elevation, this is 10 meters. The platform elevation here, this is 10 meters above the high water mark, and it's 48 meters inland. And yet those storms had enough energy, you know, the bore came up, basically had enough energy to completely shatter and break up this rock and reconfigure it. So think of the energy that is involved to do that, and now think of how how your house will fare on the coastline with that type of energy. Okay, here's another before and after here. So this is 2013. Okay, so you can see this here, this stuff here hasn't changed much, but what you can see here, you can still see the slope here. And you can see that the rocks, this has maybe been broken up here into multiple pieces, and parts have been sheared off and broken down in this cliff. The boulder ridge face has been reorganized, and so on, okay? Okay, so this is another image. Now this is that massive, I believe these are before and after images of the two largest blocks moved during the storm. Okay? So what this is this shows you one of the big boulders here, and then this is in 2009, and this is after the storm here. It was shifted, and they don't have a picture of it, but it looked like this in 2013 before those storms, and then afterwards it was moved and rotated. Okay, that's boulder 267, which and then this one here, look at this. Okay, this is in This is a before and this is the after. Okay, so so first of all, this piece on the top here, this is this piece here, this little slab on the top had a mass of about 60 tons. Okay, and it was dislodged by the storm waves. It was taken off. And this whole thing here was moved and rotated. And I believe this is the 620 ton rock. So let's go up and have a look at the beginning here. There we go. This is boulder 293. This is another view of it. This is a 620 ton boulder. So the 60 ton chunk that was sitting on top was washed off by the storm water. The rock is exposed. It's not the same color underneath. It was protected, right? And it was scraped. And this whole thing was actually shifted and moved. 620 ton rock. We can go back down here and you can see this is what it was before, this is how it was moved afterwards. You know, the whole thing, you know, and this is how high above sea level was this. It's in the details here. Don't see it here offhand. Okay, the center of mass moved 2.5 meters for the 267 boulder. And this guy here, broken into pieces. It doesn't say, I don't see it. Okay, so the point is there's huge amounts of energy in these waves. Now let's have a look at, now this paper also came out in 2018. And it was France, and it's a similar study, and I'll just go to the diagrams here. Okay, so this is now so we talked about the Ireland coastline. This study is in Western Brittany here, on this coastline here. So this is the study site. Okay, so various islands and stuff. There's pictures of the debris fields and the boulder fields. It's a very high energy coastline, like Ireland. Okay, it shows you some of the ridges, the boulder fields, vegetation, so those have been around for a while. Seaward, different slopes of the elevation versus distance from the shoreline. Okay, now this was interesting because they used a kite here, right? If you use a drone, it can only stay up for 20-25 minutes typically. Okay, so that they used a kite here. This is the operator. He's just flying a kite, which is up here. And underneath here, there's a camera attached, okay, and gimbals and stuff. And the camera can do scans and take data, right? Identify where all the rocks are, etc. Stitch them all together and record where the rocks are at one time and then record them after huge storms another time. So this is before and after. I'm going to zoom out a little bit here. So this is interesting. So this is a change from 2012 to 2014. So the blue areas are drops in elevation where rocks have been removed from this area by the storm action. And the red areas are where they've been deposited. So 2012 to 2014, a lot of change. Okay, this coincides with the 2013 to 2014 winter storms that moved the rocks in Ireland. This is 2014 to 2016, not so many storms. Blue areas again, material removed. Red areas deposited, and then 2016 to 2017. So what it's showing is this is the mean water level, if you like. So what you can see is this is the area of the storms in 2013, 2014. There's some storms here above a threshold, but you can see where the rocks have moved. So you use your kite, you do your scanning, and then you do it again and do it again, different times, and you can see the movement of. So this is a very interesting other way of looking at it, but it does show significant movement of the coastline.